Hello friends, I am Balaji and today I am going to discuss with you about one of the very interesting topic in C#, which is known as delegates. So first of all, we want to understand what is delegates. So delegates is a pointer to a function. So if you already know C, you will already aware of what is pointer. So what is pointer? Pointer is nothing but a special kind of variable which is used to hold the address of another variable. Normally a variable is nothing but a container which is used to hold a value, but a pointer is a special kind of variable which is used to hold address of a variable. So similarly, pointer to a variable is nothing but a pointer or a holder which is used to hold or which is used to point to function, which is used to point to address of a function which resides somewhere in the memory. So in C#, pointer is a reference type, means it's a class and it is used to hold a reference of a method. So all delegates are implicitly derived from system.delegates. We can create delegates on our own type, we can name it by our own, and then basically it all derives from the class called system.delegate. For example, if we create delegate, some method name void sample and open brace close brace, now it will create a class called sample which is derived from system.delegate. So only this sample will act like a delegate. So now we will see what is the features of these delegates, why we want to actually use these delegates. Normally we can call these functions through its name itself. Why we want to call this function through its address? So one of the very basic feature of this delegates is callback mechanism. So what is callback? Now we will see some of the abstract of this callback mechanism and event handling. Later we will explore it very deeply. So first of all, what is callback? Callback is nothing but in simpler term, what is callback? So when we call a function and that function, that target function which we call, in turn calls our own function, it's known as callback function. I will repeat it again. When we call one function, it can be any library function or it can be any function on another class, and that function in turn calls our function, means that mechanism is known as callback mechanism. This delegates is highly useful for that callback mechanism. Now if you can't be able to understand this callback mechanism, don't worry, we will within a short time we will explore it very deeply. And then the second feature of this delegate is event handling. Normally if you work with any graphical user interface applications, means you already aware when you click any button or when you click any something, any controls like a combo box, radio button, checkbox, some events will get triggered. For example, if you write any online form and then you click submit button, so this submit will actually submit what all the content you have entered into some server database, like that. So normally when you write C program, it will actually execute sequentially, it will not execute based on any event. But in graphical user interface application, the event will run the application. So only it's known as event derived language. If the user click one button, the application will act based on that input. So only it's known as event handling, event driven programming languages. If you create one application, for example, if you open your calculator app, you type 12 plus 12 is equal to, at the time if you press equal to, it will compute the value which you have entered previously. For example, 12 plus 12 means it will compute the value 24 and then it will display it. So all these mechanisms internally use delegates. We will explore how it works and then we will write our own event handler in the future lecture. But just to know, these are the two major features of these delegates. So now we just recap what we learned in our C programming language. So this is a simple C programming language. Don't worry, we will not dive into this C programming very deep. We will just see what we will do to store our function address into a pointer, and then we will go to C#, how it works. So in C, normally if you create a variable like this, int a is equal to 10, so here a is a variable which holds the address 10. So if you want to store this address of a, means what you will do, you will create a pointer of the type integer, because you want to store a variable of type int. So you want to create a pointer of type int, and then you will store the address of this variable in this pointer. So now ptr1 will hold the address of this a. It will reside somewhere in the memory. So this ptr1 will hold the address of that a, and then what the star ptr1 will hold. Normally star is a value at address operator. So star ptr1 will fetch the value in that address which the ptr1 holds. So normally it will fetch the value of a. Similarly, how a pointer to a method works. For example, this is a function which we want to call. This is float display. It receives 2 arguments and it returns a float. Its name is display. So if we want to call this function, how we will call? If we want to call by its name, means we will just use display, and then we will pass some 2 integer arguments like that. But if we want to call this function through the address, means first if we want to create a pointer of that type. So here the function will return float. So here in this pointer variable, this at the starting we will declare this as float, and then what is the second thing which is appear here? It is the name of the function. So we want to write a name of this pointer. So within this parenthesis I will write star ptr2. This is the name of our pointer. So the in C our pointer will always begins from this star operator. So I will use star ptr2, and then this what this function will accept. This function will accept 2 integers. So I have within this parenthesis I have used this 2 integer parameters. So now you will observe the one thing. So the signature of the function and the signature of the function pointer are exactly similar, except this name. All the things are same. Here also there is a float. Here also there is a 2 integers. So all the things are same except this name. So in C# also it's similar. In C# also we will use some extra keyword called delegates, and the name of the function changes. But all the things are same. All the signature are same. So now how we can assign the address of this display to ptr2? So we will do ptr2 is equal to display. Normally when we omit this parenthesis, means normally how we will call this function. For example, we will call this function by, for example, d is the function. Just assume like that. I want to call this function, means I will pass this parenthesis. So d is the name of the function, and it will actually give the address of this function, and then within this parenthesis we initiate the compiler to call that function. But here we haven't put that parenthesis, so it will just return the address of the function to ptr2, and then now we can call this ptr2 by these 2 ways. One is star ptr2 1,2, and the another way is we can directly use ptr2 to call this function display. So now we will see how we can declare a pointer to a function or a delegate in C#. So I will change this to pointer. We will use a keyword called delegate followed by a function signature to actually declare a pointer to a function. So here is the syntax. The first one is the access specifier. Normally in all object-oriented programming there are access specifiers. There are a lot of access specifiers like private, public, protected, like that. So first we want to specify our access specifier. Then we want to follow this by delegate keyword. So this is a keyword which makes this all the remaining things works similar to a function pointer. Then we want to pass the return type of our function and then delegate name, which is similar to pointer name, and then within the parenthesis we will pass the parameters. So what are the parameters this function will receive, like that. So we will see one small example of how this delegates, how we can declare this delegate. So here is that. So here first we write public, means this is the access specifier. We are saying this delegates is globally available to anyone who use our class. So public is the access specifier. Then next it is followed by a keyword called delegate. So delegate is makes our this print delegate as works like a pointer to a function. So this is our function. I have marked this as bold because this thing is exactly similar to our function declaration or function prototype. For example, normally in C# we will use this return type as first and then followed by this name of the function, and then within this parenthesis we will pass the parameters list and then we will write the instruction. So public delegate, what type of function we want to hold? We want to hold the function whose return type is void, and then it will accept two parameters it will accept one parameters which of type integer. So we instruct the delegate to create a function pointer of this type. Normally it will create a class. We will explore it later. So this is one of the full example of this delegates. First I will create this function. So I want to call this function through its reference. So public void print number int num. This is the argument. This is the function which accepts one integer as a parameter, and then it returns void, means it doesn't return anything. So I have specified void there. Suppose we want to store address of this function to delegate, means how we can use it, how we can declare a delegate. So here I have used access specifier as public delegate void because the function print number returns void. So we have also declared a delegate return type also as a void, and then followed by a delegate name, print number delegate. So these names cannot be same, and then this function accepts one integer argument. So I have used this parameter as a integer. Now semicolon. So this thing and this function signature, function prototype is very similar except this delegate keyword. Now if we want to call this print number using this print number delegate, means what we want to do? We want to first create the object for this delegate. In the previous slide I have tell this delegate will create a class, and then it will import it will extend the class from system.delegates. So if in this line it will create a new class of name print number delegate, and then it will import this class from system.delegate namespace. This system.delegate namespace only give the power to this print number delegate to act like a delegate. Okay, this class will contain two functions, which is one of the special kind of function called constructor, which will receive one argument, and then the next function is a invoke function, which is used to invoke our function. Okay, so here print number delegate, normally how we create object in C#, class name followed by object name is equal to new class name, and then what are the arguments we want to pass to that constructor. So here also class name, in our case class name is what? Print number delegate, and then object name I have keep that as print is equal to new space class name. Within the parenthesis I have passed print number. What is print number? Print number is the name of our function which we want to call through its address. So I have passed a print number without parenthesis. See, listen carefully. We pause parenthesis mean it will not return the address, but actually it will call that function. So if we want to pass a reference of this function mean, don't include that parenthesis, it will cause a lot of problems. So avoid this parenthesis. Print number. Now it will invoke the constructor of this print number delegate, and then it will store the address in one of its variable, and then we will call print dot invoke 5 means it will how we will invoke any method inside any object. So we'll use object name dot method name invoke. What it will invoke? It will invoke our function print number. Because how it will invoke? Because we at the time of object creation itself we have passed the address of our print number to that print number delegate class. So through that address it will call our print number delegate, and then pass that it will call our print number function, and then pass this 5 to that print number function, and then it will print number 5. So this is one of the way to use this delegate. And the another way is this line is common to this code also. We will start from here. Print number delegate prints equal to, here I haven't create any class to it. I haven't create any object to it. Print number delegate print, this is object name, is equal to print number. Here I haven't specified any new print number delegate of print number, I haven't specified this all. I have passed print number address to this print number delegate. It will create object, and then it will store all the things internally for us. And then when I call here also I have used this print as if like a normal method. I haven't used this like a object. I have normally used this as a normal function, print of 5. Now what it will do? It will this print will hold the address of our object which is present in the heap, and that object will hold the address of our function print number which we have passed here. And then through that address it will call our print number function, and then it will pass 5 to it. Okay, and then it will print console dot write line number 5. So now we will see one real-time example. Before that we will see what are the types of that delegate. One is standard delegates, which we have seen in our previous slide. This the standard delegates is the delegates which is created using delegate keyword, and then the next type of delegate is action delegate, and then followingly function delegate. So what is action delegate? Action delegate it's a special kind of delegate which will not return anything, which means which will return a void type. And then the function delegate is a special kind of delegate which is used to return any kind of values or any type of values. So it is similar to void function pointer. It is similar to any function other than void function. So all these things are similar. Whether all these things are similar or whether they all are different, we will explore it later. But now we will have one short demo on how to use this delegate using our Visual Studio. So here I have created one new console application in my Visual Studio. Now within this class program I will create one new function, int add. It receives two integer, int a comma int b, and then I will return the value of a plus b. Return a plus b. Next I will keep one more function, float. It will return float. Sub, and then it will receive two integer, so here I have to keep two function which I want to call. So within this main function I will create, first of all I will create an object for this program class, because my class name is program. If I want to access these two functions, I want to first create an object for this program class. Sorry. Now I have created an object for this program class, and then I will receive, first of all I will receive the value of a and b from the user. So I have keep two integer variable x and y, and then I will receive variable from the user for this x and y. X equal to console dot read line. It will read one line from the console and then it will return to this x, and then y is equal to. So right now these two lines are showing error. What is this error? So cannot implicitly convert string to integer, because this read line will return a string. It will return the data as a string, even though we will pass integer like 4, like 5. It will convert that to into string, and then it will return that resultant string to this x and y. But basically this x and y are the type of integer, so it is saying that we can't able to implicitly convert this string to integer. So we will provide a way how to convert this string to integer. So we will use convert dot to int32 method to convert any string or any data types to 32-bit integer. So convert dot to int 32. This is the function. Within this argument, within this open parenthesis and close parenthesis, I will pass the result of console dot read line. So if I pass any value like 45, the console dot read line will return that 45 as a string. It will go to convert that to int 32 method. It will cast that string 45 to integer 45, and then it will return that integer 45 to x. Now our x will hold integer 45, not string 45. Similarly I will do convert that to int 32 here. Now we will use a normal method to call this a and b. Object program dot add a comma b, sorry, x comma y, and then I want to print the output to the console. So console dot write line. And then object dot sub. So this is a normal way to call this function. I have called this function add and sub using its name, and then I have passed the value x and y to it. Now I run this function by pressing Ctrl plus F5. So it will first, we want to first pass the value of x and y to this console. So I have passed 4. It will return 8, because first we have called add, so 4 plus 4 8, and then I have called sub, so 4 minus 4 0. We will close the console. Now we will change this project to call this function using its address, not by its name. So within this class I have create one new type called delegate type. So public delegate name, add delegate. What our add delegate will receive, it will receive two integers. So int x comma, otherwise I will use the same variable name. We can use any variable name, I will use the same variable name, add. And then what it will return, it will return a type of integer, so int. And then I also want to call this sub using its address. but its signature is different from this function. So I will create a new delegate type. I will actually copy this and then I will modify this. What this function will return? This function will return float, and then I will change the name of the delegate to sub delegate, which is used for subtraction operation. So now I will comment these two lines. Now when I execute this line will create a new class called add delegate. So it will create a add delegate like this. So we will copy this class, system. It will extend this class from system dot delegate or suppose if you want to use the same handler to store the address of different functions, it will import our class add delegate from multicast delegate class. It will this line public int add delegate int comma int will generate a class like this, and then within this class it will create two special methods. One of the special method is constructor. So how the constructor will look? It will always the constructor should have public sets access specifier and then name of the function, and then it will collect the address of the function which we want to call. I will use add here just for reference, just for you. I am typing this. We actually didn't want to type this and all. It will automatically generated by the compiler itself. I am just typing for you only. So it will actually store this in one delegate, and then it will have another one method called invoke. So I will use public void invoke. It will contain an argument list. And then within this function it will make a call to this add here and then pass so this single line will generate all these things, but we didn't want to manually write all these things. It will defaultly generated by compiler for us. Now we want to create an object for this add delegate. So how we will create object for our class? We will first use class name. In our case, what is the class name here? Add delegate is a class name here. Now only I have shown how this class looks, what are the methods inside that class. Actually this class contains lot of methods, lot of data and all, but these are the important things which we are going to use in this project. So add delegate, this is the class name followed by object name, object add delegate, this is the object name which I want to use, is equal to new add delegate, and then here our intelligence shows add delegate target. So we want to pass address of the function which is similar to this prototype. What is the prototype here? This is it actually receives two integer and then it returns one integer. So here this function it receives two integer and then it returns one integer. So both of their signature matches. So I will pass address of this add function. How we can pass the address of this function? By its name without parenthesis. So add. We can't able to directly call this add because this add belongs to this object program reference. So I will use so before we actually pass this object program data add, I want to say another thing to you about a delegate. I have previously said delegates is nothing but a pointer to a function, but one of the major, it is one of the popular use of delegate is it's a type safe pointer to a function. What is that meaning of this type safe pointer to a function? So here our add delegate, we have insisted to accept a function which returns integer, and then that function should receive 2 integer. So here we insist add delegate to accept a function which will accept 2 integer as its parameter, and then that function should return int as its return type. That function should keep int as its return type. Suppose now we will pass address of sub, and then what it will say. So right now it is showing error. I will keep this. It will show float program.sub in command have wrong return type. Means here it is saying our return type is wrong. We want to have a function which should have a integer as its return type. It will say argument list are correct. Here also we have 2 integer as its arguments, and then here also we are having 2 int as its arguments. So its argument lists are same, but its return types are different. So it's a type safe. We can't able to pass any function which is not equivalent to the type which we have declared as a delegate type. So I have passed object.add. Then I will create a object for subdelegate. So class name, object name is equal to new subdelegate, and then it will return address of the type subdelegate. So here our subdelegate function wants a function that accepts 2 integer, and then it should return 1 float. This function match this signature, so I will pass object program dot sub. Now I want to call these functions through its address. So object program dot add will actually what it will do, it will call the function through its name, but we want to call through its reference. So add delegate dot dot invoke. So right now it is showing it wants 2 integer as its argument, and then it will return int as a return type, because since we have passed add as its address to this add delegate object, it will show the signature of it. So we will pass x and y value which we have received from the user, x comma y, and then we will print this result in our console. So console dot write line. I will append it by someone. Add result. I will use a placeholder 0 to actually refer to this. Similarly, I will call sub function. Instead of add delegate dot invoke, I will pass object subdelegate dot invoke, and then I will change this to subtract result. Now I run this function. I want to pass two integers 6 3. So first it will add these two things and then it will return 9, and then it subtract these two things and then it returns 3. So our function perfectly works through call by address, through pointer to a function. So now we will explore these two lines still better here, object.invoke. So before that we will use another way to call this function. For that I will just copy it again and then I will modify it. Says add one result and then subtract one result. So instead of saying this object add delegate, we can say object add delegate, and then we can use this object. Actually what is this object add delegate? It is an object. We can use this object to work like a function. It's not actually a function, but we can simulate it like a function, so that we will be very convenient. We can use this object as a function, so it will make us very easy to use this function, use this object. And then similarly I will delete this invoke. So what this line indicates? So even though we haven't passed it dot object add delegate dot invoke, it will internally generate a code object add delegate dot invoke, and then it will pass these two arguments x and y to that invoke function, and then that invoke function in turn calls our function add and sub. So now I run this function. I pass two things 5 and 54. So by adding these two, and I will get 59. Here also I get 59, means these two things works. This also works, this also works, this also works, this also works. So now I have already told, I will explain this callback mechanism later. Now I will explain it detailedly. Now what I have done here I have done object add delegate dot invoke, and then I have passed some arguments to its x comma y. Here I haven't called this add and sub directly. I have called some other function called invoke. But how our add and sub gets called? So now consider this line only, not you didn't want to consider these lines and all. Consider this single line. So object delegate dot invoke. Here we are calling invoke method of this object add delegate object. So we are calling this invoke function, and then that invoke function in turn call backs our add function. So these things is known as callback mechanism. So we are calling one function and that function in turn calls our function. It may or may not be our function. It will call back the function which we want to call, but we are not actually directly calling this add and add, but we want this invoke. Actually we make this invoke to call our add function. These things is known as callback mechanism. This is popularly used on all real world applications. We will see what are the applications which use this callback mechanism in our later videos, but right now we will continue our discussion on these delegates. So now we will quickly see one more way to call our add and sub function through this object add delegate and object sub delegate. Now here what we do, here we are creating an object for this add delegate, and then we have passed our reference which function we want to call to this add delegate and to this sub delegate. Okay, so right now we will change this line somewhat easy to use. So I will comment these two lines, and then I will actually copy this first line, and then I will copy this second line. So instead of using this object add delegate is equal to new, add a delegate program, add. Instead of this long line, we will make this very simpler. Object or delegate is equal to object program dot add. So it also works. It is not showing any error, means it's also similar to this line. Object program dot serve. We will run this program once again. I will pass value as 4 2. It will return correct result. It returns correct results. Okay. So right now we will explore these two lines now. So now when I create this add delegate, and then when I return this first line, what it will do? In stack memory, it will reserve 4 bytes, and then it will initiate it to null. And then once I have used SQL to object program dot add, what it will do? It will, what do you think? You will normally think it will store the reference of this add function to this object add delegate reference in this stack, but it will not actually happens like that. What it will do means, it will object or delegate will first create a reference in this stack. When I will split this by 2 line. When I execute this line, it will create its reference in this stack, which is used to hold address of our object. And then when we say this object add delegate is equal to object program dot add, first of all it will create a new object for this class object delegate, and then it will pass this argument as the argument to its one argument constructor, which we have seen in this line. Means even though we have written the program looks like this, very simpler, it will internally gets converted to this big line. So these two lines are same. So right now we have seen what is delegate, how we can use delegate in our C# application, what is callback mechanism, how it actually works, how we call our own function, that function calls our function, how it happens. We all seen all these things. In our next class we will explore all these things once again. We will actually recap all these things once again, and then we will explore further what are all the things we can do with these delegates. We will see what is system, what is action delegate, what is function delegates, how it differs from delegate, or whether these three are same, and then we will explore a lot of things. Thank you for your kind viewing, and then subscribe to my channel. If you have any doubts, you can free to comment it on my channel. So thank you once again. Bye.